Howdy, folks. Just waiting for confirmation that I've gone live. Which it looks like I have. Welcome to the live stream. I think it's number 9. Yeah, where we are porting the J programming language codebase from C to C++. If you're tuning in for the first time, feel free to leave a comment in the chat and I'll shout you out. Today, I'm streaming in ultra low latency mode, so let me know if that causes any issues. It's supposed to give the best experience for interacting with the chat, which typically in the past videos there's been a little bit of a delay. But yeah, let's hop into things. So today we're going to start off by reviewing some pull requests that I have not had the time to look at. So the first one, I believe this is going to refer to a number of issues. So let's just read through this. This should fix or address a couple of different issues. The technical write-up is in number 87. So yeah, I set this issue up in I think the very first live stream of Refactor Me. And oh yeah, thanks for that. To add a bit of documentation, the current implementation without the type case is the following. Related to this, we have two constants in j.h, define nummax and define nummin. The value of nummin is actually -10, see gobbled, but there must be a better way to visualize this. This matches the min-max values of bnum. This looks to me like these are some kind of static singleton values. Instead of creating a new a every time you need these numbers, you could just get a pointer to a static value. So there's a number of possible refactorings. After reading some more code, the definition of num and refactor num is Hey Joao, how's it going? I have officially finished watching every single one of the XLA talks in that playlist that you sent me. So yeah, thank you for that. Very interesting. I need to learn more about kernel fusion and JIT engines, and why it's necessary. Is it not necessarily that? Is it necessary that you can't do it at compile time? Internship. Where are you interning? And are you a university student? You seem to know quite a lot about Julia and all this machine learning compilation stuff for someone that's still in school. Yeah, still at university. Very impressive. 2023. Well, let me know when you're graduating. um, I should try to get into the TPU alpha program. Interesting. I'm not sure I qualify as a researcher, but sure, yeah, feel free to ping me the link. I mean, from what I know about TPUs, they're basically like less general GPUs that are optimized for like matrix multiplies, which is, I guess, good for machine learning and anything that makes use of matrix multiplies, but like for more general computing, it's not as useful. Interesting though. And yeah, I'm very curious too. I think I brought this up at the meetup that GitHub TensorFlow. Or I guess, yeah, you sort of answered that. You said that like JAX is more what people depend on. Let's go to JAX. Google JAX. So does this also depend on XLA somewhere? So let's just look up XLA in this repo. Shows up 138 times. Yeah, that would be pretty cool. JAX interpreter. Anyways, somehow they hook into it. But yeah, we'll look. I'll take more. I'll continue to explore this off stream. But yeah, it's very cool stuff. Anything that can do kernel fusion and generate code for CPU, GPU, and TPU is all pretty neat. All right, back to refactoring here. So, Herman or Herwin suggests replace the check with something more descriptive. Okay. So let's just take a look at the code. Although there's 74 files. So it just replaces num0 with j false. 0 I1I with num as well. Num1 with true. J true. So let's go to so that ultimately will be removed. this has been deleted. Applicable for num. Interesting. I like it. It's a step in the right direction. Let's go back. What was the conversation again? For the Booleans, instead of array of 2, the values could be just introduced individually. Yeah, I agree in the long run. Not hiding these in type defs or macros is the way to go. So looks like a great start. We'll merge forward to follow-up PRs. And it is passing CI. So yeah, this is +1, submit review, and merge pull request. Why did I choose to port J again? I would have chosen APL, but APL is not open source. And I also figured that there is a benefit to porting J because J was Iverson's final language, whereas APL was Iverson's first language, which means that technically all of Iverson's brilliant ideas all exist in J, whereas some of them won't have existed in APL. And the goal here is to get inside the mind of Iverson and learn all of his genius. That's why we're doing this. So, yeah, that's basically why we chose J. And K is also totally closed source. Q was sold, which is just a wordified K, and so that's closed source as well. So basically J is the only OG like array programming language that exists in the open source ecosystem. I know Julia is open source. I don't know if R is open source. Is R? R. Read-only mirror of R source code. Yeah, so it does look open source. And yeah, Bacon, that's Marshall Lockbaum's language. That's super new, and it's got a bunch of new stuff in it. I will definitely be investigating Bacon at some point. Also, too, this is not... It's not a criticism, but definitely this needs, like, a more consistent font. It, like, irritates my OCD that, like, this is not... It looks like these are taken from different fonts, which makes it less pleasant to code in my opinion. But definitely, yeah, this is... There's may or may not be plans in the future to start an APL podcast, and if I do start it at some point, I will definitely try to get Marshall Lockbaum on, because he formerly worked on Dialog APL's compiler, then went and created a language called I, and then he created a successor to that called Bacon. Yeah, sorry. And it's something nice about, there's something absolutely lovely about the fact that even though APL has, you know, crazy different glyphs and stuff, they all follow like the same exact sort of font style. Like there's APL Unicode 365, APL 33 or something like that. There's a bunch of different like APL fonts that, even though everything, like even the numbers are in the same font, so it doesn't borrow from different fonts. And like I think that just from like an aesthetic perspective makes it much of a nicer experience. But it's definitely on my list of things to do, to dig into Bacon. All right, so we merged one of our PRs. Let's go take a look at, so this is a work in progress. I think this one I have looked at. It feels like a terrible hack. So yeah, I will revisit this later off stream and see if it's something we want to merge. This one's not compiling right now. And then the question is, do we want to add, this is sparse. So this is a small PR. So yeah, in the future, and this is something I've started to think about, that it's probably arguably a better idea to write ourselves a version of the array struct in the J source code in like C++, and then as we port things, start to use that and just make it interoperable with the rest of the code. Because arguably this should be a method on our JArray class, like C++ class. That's const and public, and that the type information shouldn't be just like public info in a struct. And so this should be no accept, but other than that, I guess this actually isn't. It should be. Should be no accept. Hey Ahmed, how's it going? So we'll merge after this. Oh yeah, and also need to all right. I think that does it for open PRs. Let's go to. So yeah, once again, I should have done this at the top. Oh yeah, I forgot to mention, this is probably going to be a shorter stream, max 2 hours. Maybe we'll just do an hour, because I've been super busy. Oh, could that have been const expert as well? Yeah, I guess it could be const expert. Add const expert. All right, that does it for PRs. But yeah, once again, actually, yeah, let's look at the closed PRs, because I think there's quite a few of them since the last live stream. So yeah, Juho, Herwin, Robert, thank you for all the PRs. Herwin, yeah, has opened a bunch of small ones over the past week, which has been awesome. If we take a look at contributors, do our little zoom in trick. So yeah, thank you to everybody that's just contributed. I did not expect so many people would be interested in contributing to this project when I started it. But it's absolutely awesome. Herman still with the unsurmountable lead with 102,000 lines of code deleted. Juho's catching up. Probably will pass me at some point at 68,000. I'm only at 73, so 5,000 5,000 ahead. Yeah, const expert, all the things. That's a great talk by Jason Turner. And I think actually, was it Jason Turner and Bandine? I can't remember. Const expert, all the things. Yeah, it was Bandine and Jason Turner. I always prefer the C++ Now versions of these talks because they're 30 minutes longer, and typically they're more interactive with the audience. Oh yeah, some folks are asleep. Yeah, I mean, I know it's late in some parts of the world, but that's why these things get posted afterwards, so you don't have to tune in live if you want to catch it afterwards. And yeah, I guess, yeah, C++ Now, for those of you that don't know, it's a conference. If you're a student, I think it's pretty cheap. It still says accepting submissions, even though the deadline was a week ago, or 2 weeks ago now. Or what is it, the 24th? Yeah, that seems like 2 weeks ago. But yeah, registration's open. I think it's like $50 for students, $200 or $300 for non-students. And yeah, it's usually a pretty tight-knit conference, but this year it's online, so it'll be interesting to see how it changes. But can highly recommend if you're a student looking to network with industry professionals, and also just like learn a ton about hardcore advanced C++ stuff. Hello, Diced. And also, yeah, hello, Raj Soni from India. Welcome to the stream. Yeah, so I think at this point we are going to... What are we going to do? We're going to pull... Ooh, wow. I guess that made sense. And yeah, what are we at now? Cat... We're at 80,000, so we're actually almost below 80,000 lines of code, which sort of makes me want to go delete some stuff, but we're not going to do that. We'll save that for a different day. Now what we are going to do is we're going to go back to what we were doing last stream, which I said we would revisit. Why do you post your city/country in the stream? Just because at the beginning I said if you want to say where you're tuning in from, I'll shout it out. I'm currently in Toronto right now, but yeah, if you don't want to share it, definitely you don't have to. Yeah, we're gonna go back to take and drop. Oh yeah, so live stream lessons we have not. Pickering. Oh, so you're just around the corner. Pickering is outside of Toronto for those of you, unless if it's a totally different Pickering that I've never heard of. We're at 24th. Oh yeah, and actually I meant to highlight a YouTube video from Bob, who's a frequenter of the stream. Bits of J. Yeah, and this was a super cool video where he shows this trace facility that actually like is very similar to something I implemented in the first APL interpreter that I wrote. That basically like traces the incremental stages of the evaluation of a J expression. But unfortunately, you need to download some package, which I don't have locally at the moment. But yeah, super cool. I highly recommend checking this out. Bob posts J videos, which are very useful if you're trying to learn J like I currently am. So yeah, can recommend this as well. So yeah, actually we can add that to our things learned. Learned about Jay's trace function from Bob's video. And yeah, let's go back to, so yeah, let's spend at least half an hour working on this, and then we'll see at the end of the half hour if we want to call it a night for the stream or we want to keep going. So where we left off last time is we had gotten a couple stood mismatches. Oh yeah, should we said last time that we potentially might write a Variadic stood mismatch. So maybe that's what we should do. Except it wouldn't be called mismatch. So sure, let's go do that. Let's go do it in Godbolt though. Godbolt. Whoa, that's bright. I apologize. Where are the options? Settings. I apologize for that super bright screen. Trying to zoom out of here. And all right, let's code an algorithm. So first, let's just do a super simple version of mismatch. So we'll call it zip find. We will not use C++ 20's concepts yet. Do I need a capital C here? No, it's still gonna whine about this stuff. All right, so this is fine. Type name. And actually we want do we need two different ones? I1 and I2. So what do we want to do? We want to wall F does not equal L. And at the end of the day, we're returning, for now, we'll return a stood pair of, it will be, except this needs to be F2. And I guess actually we don't need the one here. It sort of irritates me, the asymmetry between the first I and the second I though. Of F and F2. So, oh, maybe zoom in? Yeah, sorry. Let's do that. Yeah, I zoomed out at the beginning. I don't know why I did that. Probably just out of habit when I see that I'm above 100% zoom, but we need that for the stream. So if pred of F and F2, then return the same thing here. And let's just write a couple unit tests. Obviously, we're not incrementing. Actually, yeah, let's increment first. ++f, ++f2. So autoconst a equals std vector 1, 2, 3, 4, 5. And here we'll go we need to add, actually we could just do a vector up here and a dot c begin, a dot c end, b dot c begin. Let's move this over here and stood equal to. And if we go stood c out, actually let's do our, where's the libraries? Format and replace this. Yeah, that's a good point. We'll have to add a check for that, Robert. Include, what is it, format / core.h, I believe. And then it's format print p dot first. Actually, will this work? So why is this outputting 0? If the predicate returns true, then return this. So actually, we can simplify this to just a break. Can we just put 2 of these and then go star F star F2? All right, so we get our 1 0 2 1 3 2 4 3 5 5. So actually that doesn't really help us. So let's go 10 and let's go 10. Or 9 just for fun. And I don't like that this is 2 digits now. So it's iterating past. Right, because we're not dereferencing here. There. Now this is what we want. All right, perfect. So actually, I'm not sure what is the behavior on stood mismatch if one range is shorter than the other. I know that there are overloads of this that take both sets of iterators, meaning a begin and end, which is the recommended use. So yeah, the ones that take first one, first two, last two. But for so let's just look until C++ 20. So yeah, this is number 3. Looking for length, looking for size. Returns the first mismatching pairs. If last two is not provided, it denotes first two plus last one minus first one. What does that mean? So that means the range of your first range plus the starting iterator Oh, I see. Yeah. It's just saying that last two is equal to this. So yeah, it assumes that they're the same range. So I think we can do the same. Yeah. That's my executive decision. Is there a way that we can... does this work? It does not. Because I think, yeah, I think we need to keep it separate. All right, so that's easy enough. So what if we have zip find 3? We call this I3. We call this F3. And then we add a 1 here and delete that. Oh yeah. That doesn't work, does it? I guess it has to be a tuple, which I think requires including something, but we'll get to that in a sec. So I actually call this T. Call this C. Call C.C begin. And auto A, auto B, auto C, return A equals to B, and C equals, and B equals to C. And there's like a what? Std get to from T. I have not used the tuple API in a while, so that may be wrong. And this should be zip find 3. Hey, look at that. And I apologize on behalf of C++ for our bad API with respect to tuple. I mean, technically we can do auto x, y, z equals t, and then do this. I think. But that sort of adds a unnecessary line of code. This showed up in C++ 17 structure bindings. So yeah, let's just leave it like this. So now, and this is where I'm sort of stepping out of my depths. I don't do a ton of Variatic template programming, but we can figure it out, hopefully. We want to make this Variadic. So let's call this zipfind2. Zipfind2. And we're going to call this zipfind. And I think that's the issue, right? Is that I'm not sure you can have a trailing predicate when it comes to like a trailing. So I guess we could put this at the beginning. But let's just go Stack Overflow it, creating a C++ algorithm that has a variadic number of ranges. I'm not sure we want this fluent C++. This is it's a great blog for those of you that don't know. It's by Jonathan Bacara. I don't think this is what we want though. Variadic number of arguments. I think this is just yeah, so this is the syntax, type name, ... So, well, let's check this. Does it always variadic functions? Right now I'm trying to figure out what the restrictions are. Do C++ Variadic templates need to be at the end. Variadic arguments don't have to be last. Well, what should we call this? Others. We'll rename that. And the syntax was and then others. So ... F's. So actually, yeah, let's just call it I's, plural. And then this is going to get very tricky. We might need to go figure out some fold expression stuff. Except it's not even folding that we want. We want like mapping over a... You can pass the Variadic args to the lambda 2, and in the lambda do the expansion. Have a good night, Joao. Yeah, so this is for down here you're talking about. So the question is, how do we get something to apply to, like, does this apply to each of the Variadic arguments? I guess we'll find out. Doesn't seem to like that. So first let's look at the error. Expected semicolon before ... Oh wait, I started doing this to zip find 3. So wait, call this zip find 3. Copy and paste this up here, and then call this zip find. So there could be a how to decrement parameter of pack in C++. All right, here we go. Expands to so this seems to be okay. Parameter packs not expanded with. Fergus says void plus plus fs comma dot 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 is the fold expression you want, I believe. I doubt that this is the case. So yeah, let's add it back. So you're saying void plus plus fs comma why is that the code that works? And also too, it says I guess that would be odd if this only works in an argument list. But yeah, let's just check now to see if this works just by doing that. So what's the problem? No matching function call to zip find. Is that what you're talking about now? So maybe we do have to leave this alone and then do the... That does indeed only work in an argument list. Argument list is different to comma operator. Interesting. So how do we do this then? Auto dot dot dot. Actually, it should work with like an explicit can't you call a for each on that? I do not know what you mean. All right, we're close, I think. Three provided. Template argument deduction substitution failed. Candidate expects 3 arguments, 5 provided. So yeah, we are providing 1, 2, 3, 4, 5 here. Zip find has 4, but a variadic argument in the middle. Let's test something out. Actually, let's just keep this so that we can revert back. It's now failing to compile just because I made that small change. Why is that? No match for... What if we... Oh, right. So now let's put this like this. Is this working? Interesting. So let's call this 4, 6, 6, 6. Interesting. It does seem to be working. How irritating is that, though? That's pretty irritating. That you need to... So the question is we technically have a variadic zip find working now. The question is how do we get the other version working? So we're so close. But we need to uncomment this, and we need to figure out, so do we need like a C++ 20 concept here? I think how to get, also isn't there like a dark mode now? Google, or is that only in Chrome? I already have dark turned on. Okay, well, anyways, I apologize. I'll get it sorted out for next time. Is invocable? Yeah, maybe. You think if we just spin A on pred is invocable, that might make it work? I mean, I don't think it'll make it work, but what is that? That's in traits, right? Yeah, it's in type traits. Did I spell that correctly? Oh, I need a type name before this, don't I? Do I need like a colon value? I think I have spelled this correctly. It just is not working. So let's... Maybe you could print the size of ... ls. So make sure it's the expected number. I don't follow that. So let's get rid of... And what if we go stood invocable? Whoa, we still haven't... No, yeah, we did turn back 1, 2, 3, 4. Oh, yeah, actually. So maybe... Do we? And actually, let's drag this... Yeah, down here. So we're back to no matching function call. So it doesn't look like concept work. Should we try... Well, if concepts didn't work, spin didn't work either. Actually, what if we do the different spelling of concepts and we leave this out as a template parameter? Oh, interesting. It's the same difference. It converts this into a template parameter anyways, which I guess is expected. All right. Well, we're 15 minutes away from 8 o'clock here. I think stood invocable might an argument type list. It's possible too. Well, I mean, actually, so yeah, let's avoid concepts just because I don't know how much of concepts are implemented in 10.2. And let's go back to type name p, type name std enable if t std is invocable. Yeah, it just doesn't like it. So yeah, the question is, Fergus says a function parameter pack that does not occur at the end of the parameter declaration list is in a non-deduced context. Looking at the standard. So does that mean it's not going to work for our case? Okay, well, so then the question becomes, we delete this. Do we prefer explicitly? Why is it not right? Because we need to. So it seems the way the cookie crumbles, this is the way it would need to be used. Do we yeah, so that's another option too. Robert's saying that we could put the predicate at the beginning, which is still kind of irritating, but I guess that could potentially just be the pattern for variadic algorithms, is that ranges always have to be at the end. Do people prefer just like hard-coded, zip find 2, zip find 3? I mean, that's what Haskell does, right? They just hard-code them all up to a certain number. Or do we want to do something like Robert's saying, is either have it second or put it at the front and then call it a day? So yeah, the alternative probably is nicer than what we have currently. And then that way at least all the iterators are together. Yeah, it doesn't bother me too much. All right, let's ship it. And where do we put this? Let's go here. Tree. Do we just put this in a file called algorithms.hpp? Where does std tuple live? Is it in functional? Stood tuple CPP reference. It's in the tuple header. For now, we're just going to put a brief. Variadic version of stood mismatch without yeah, I mean, let's call it that. Technically, there's a detail here of the fact that stood mismatch has a baked-in negation on the predicate, but that's a detail that's not important for now. Let's go to cMakeLists, JSource, put this at the top. Algorithms.hpp. And then if we go back to take and drop, and so if we get this working, we'll probably call it a stream. And last time I said on Thursday that I would do one on Saturday, but then my plans changed. This time my plans will not change. So we'll do another stream where we will continue to work on this a bit more on Saturday. So yeah, let's come up here, include algorithm.hpp. Hopefully it can find that. And currently says it can't find it, but we'll see if that's the case. And where did our loops go? So yeah, this is what we wanted to convert. So let's change the T's to UIs. And this is then going to be autoconst cc equals, oh, we should put it in a namespace. What should our namespace be? Namespace should it be 3 letters, 4 letters? We could just call it algo. Until I have a better suggestion, JCPP. We want it to be something, I don't know, that indicates algorithms. So specifically, this will be a namespace just for algorithms that we write in the like STL style. And so it could be like JAL. What is it? So STL stands for Standard Template Library. Yeah, it could be JAL or I don't know. This is good for now. Look at that. So we need U, we need IV, and we need S. And this is just from 0 to M. So U seems to be the first one that we look at. So U plus M, S, and then IV. And interesting that we use mismatch. I wonder if we got, well, the test seems to pass, but I wonder, we must have gotten the negation right. But our, I sort of want to go look at that though. Oh yeah, does my client format work now? It still doesn't work. So A is U, C is IV, I'm pretty sure. Actually, I can't remember what the line column limit was, but could be worse. We still don't know what CC is. What are the odds that worked on the first time? Very low. We need to build. Algorithm.hpp. So potentially why can't it find this? So where are all my C++ files so far? And where did I put array.hpp? I put it in JSource. What folder it is in? Yeah, it's in JSource. Let's go back to our CMake list. I guess we can put this next to here. I wonder if we need to remove our build folder. Oh, algorithm.hpp. What did I call it? Algorithms. What do we want to call it? What's the standard header called? Algorithm, yeah. Let's just call it still doesn't seem to be happy, but that's okay. So now let's build this. We're missing a comma. Right, and this should be does not equal. Ooh. This is returning us a tuple. So technically we would need to go like std get. That's irritating. So let's just call it t. The HPP shouldn't be in the sources. What do you mean? So like it shouldn't be in JSource? I mean, it looks like there's header files in here. Oh, it automatic. I see what you're saying. We can omit it from CMake lists. Wrong CMake file. So actually, both of these can be removed. Is what you're saying. Actually, well, let's go back to this. Where did my take drop go? Just so that we get this set up, and this should be std get t or std get 0 from t does not equal u plus m. Oh, I reused T. So what do we call this? Tuple? Seems to work. And then we can replace this with the exact same thing. So this is going from 0 to m as well, and doing the exact same thing basically, except it is actually modifying JV. Yeah, woo. This is pretty awesome. I mean, I'm still a little bit torn how I feel about this. I sort of feel like we should create wrapper algorithms called like zip found. That returns a Boolean, sort of like is sorted until and is sorted. So that like is sorted until returns you an iterator, and is sorted just returns you a Boolean, which is implemented in terms of just checking whether or not is sorted until return the past the last iterator. So we could do the same thing like zip find and zip found, where zip found returns a Boolean. I actually sort of really like that, and I'm gonna go do that right now. And then technically we could use zip found up here as well. And because they're only in these ones, that's why it worked. it stood mismatch, which is relying on not equal to, whereas here technically it's the equal to that we're using, and we don't have the negation in there. So it's basically the exact same thing, except we call it zip found, and if we break, instead we just return true. Or so actually, do we want to call? What do we want to do? It's actually probably better. It's more clear if we call this using zip find. So auto const. Actually, we can just use t now. Zip find pred fl fs ... and then return std get 0 of t does not equal to L. And then over here, we can get rid of this line and then call this zip found. Very nice. So first, let's check that that worked. Awesome. Now, let's go up here and call this zip found as well. And so we can get rid of this, and all we need to do, and so note that the default binary operation of std mismatch is not equal to. So what we want to replace this with is equal to, so that we get whatever, two knots cancel each other out. And I think this should work. Oh no, it did not work. Why not? So we have std mismatch, which is, or so maybe I got that wrong. Fatal. I did get it wrong. Right. Yeah, I was talking myself in circles there. Std mismatch is just zip find with not equal to as the default operation. Right. There's no double negation here. Yeah, I was confusing myself. And then I think we have another std mismatch up here, which is the exact same thing, just with different iterators. So we can do the same thing here. So I'll go zip found std. Or so technically, there's an argument to be said that we should add an algorithm called like has mismatch or mismatched with an ed. Because technically that's what this is here. Like zip found or zip find with not equal to is mismatch. So arguably mismatch is actually a better algorithm to be using here. What do people think? Do people think we should add mismatched or has mismatch? There's no C++ algorithm that starts with the prefix has. Typically, I don't like C++, but the one thing is they have a much more easily searchable. So yeah, has underscore does not exist. Is underscore, there's a bunch of algorithms. Is partitioned, is sorted. So it could be is mismatched. Is mismatched. I sort of like that. Although it only works from the two range case, but that's fine. Auto is mismatched. Template. Return std mismatch. Ooh, except I don't want this to actually take a predicate. I just want it to use the built-in one. In the case that you're not using the default predicate, my opinion is that you should use the generic zip find or zip found versions. Std mismatch fl f2 does not equal dot first does not equal L. I need to spell type name correctly. And we need to go back here. Algo is mismatched. I kind of like the pred, though if you use a lot of custom functions with it baked in, it makes sense. Yeah, I mean, that's my view is that generic algorithms shouldn't come with default binary operations. And it's fine to have specializations of generic algorithms that have the default binary operations baked into them. So like in my opinion, if I don't think std accumulate should have plus as the default binary operation. I think it would be fine if we had std sum and std product that were specializations of std accumulate. But that's the thing, is that like mismatch is the perfect example. Really, it's a generic algorithm zip find, but due to the default binary operation being not equal to, they called it something completely obscure from the generic point of view. And that obfuscates people's ability to understand what the algorithm's generic purpose is, and it doesn't get used as much. So while I think it's fine to have an algorithm called std mismatch, I think it shouldn't have a overloadable binary operation. It should just have a hard-coded one, which is implementation-wise calling an algorithm called zip find, which is the generic one. And then people will just know, okay, there's a little tree diagram, zip find's at the root, and mismatch is an implementation of that, and adjacent find is a specialization of zip find, etc., etc. Let's double check, though, that we got this right. What? Oh, I need to include algorithm for 1. I don't think that was it, though. Take drop line 7. What is it complaining about? ACOS has never been declared. All right, what did I just do? If I comment this out, so clearly I should have been committing things. This is super obscure. Let's take a look at my git diff. There's no way it's the array.hpp, is it? What did we do? I thought we got rid of... Oh. What is going on here? Oh, yeah, you are correct. I'm missing the end of my namespace. Thank you. So let's go back, change these back to is mismatched. Fingers crossed. Awesome. This was super cool. And we have a little algorithm library started here. Is mismatched. Yeah, I think it's fine. It's, yeah. A part of me maybe thinks that it shouldn't be there and we should just rely on zip found. But yeah, I think that's where we're called for today. So let's, what did we learn? We learned about this. I wonder if there's a nicer way to do this. Learned this fancy incantation. Learned can't be in a deduced context when Variatic template is not the last it's not the last template. And yeah, we didn't learn this, but we added algo rhythm.hpp with zip find, zip found, and is mismatched, which is pretty dope. All right, let's take a look at our get diff. Yeah, we got rid of that, added a couple algorithms. Oh yeah, I don't have my Clang format working, and I said I'd get that working last time, which I clearly did not follow. Follow through on, which I will have to do. Interesting to see, what is our column limit? Do we set it to 100 or 120? Yeah, 120. So how does that actually, would this all be on the same line? No, it wouldn't, which is nice because I think it looks better this way. So we've got is mismatched, is mismatched. Oh wait, actually we're not done yet. We need to just do this one last thing here. So this is gonna be what are we doing here? We're actually not. So this actually might be a different algorithm. So actually, let's do our for loop conversion. So for for loop in64t I equals 0, I less than m. For those of you that are watching, this is do is just a macro that expands to this. So this is actually not a mismatch. That's the end of that. So this is a transform, it looks like. So yeah, it's a transform that requires 3 ranges plus an output range. So JV is our output range. U, IV, and S are our input ranges. So we'll leave that for next stream on Saturday. So this is a to do create Variadic algo transform, which should be pretty easy now that we've done it once. So yeah, I thought this was the same algorithm, but it's not. It's doing a write to JV. All right, let's do one more get diff. Looks good, looks good. Algo is mismatched. Algo is mismatched. Algo zip found. Get rid of that space and a couple extra things that we learned here. All right, let's get checkout dev. Get stash pop. Oh, what's going on here? Can you abort a get stash? Get stash. Stash abort. How do we do it? How do we do it? Git reset merge. Git reset hyphen merge. Git status. So I guess we needed to git merge main. Now we need to do a git stash pop. There we go. Git diff. Same changes as before. Gets not status. Actually, I want to build just in case. And then run our fast tests. Awesome. Git add, git status, git commit, adding it's algorithm.hpp with zip find. Origin main. Let's go back to GitHub. Go back here. Should have dev branch. Pull request. What's going on? Oh, I git pushed main. Git push origin dev. Now we go back to JSource. Yeah. Exactly. Compile and pair. Don't need a description. Assign yourself labels. C to C++. Take a look. I guess we're missing some docs here, but we can add them later. And a missing end of line, but we can fix that. And yeah, this looks pretty nice. Is mismatched, is mismatched. Zip found, and to do algo transform. Oh, this should technically be 9. All right, let's go fix it. So what are the things? End of line and number 9. So end of line here. This should be number 9. And while we're at it, let's add the docs. This is a predicate version of zip found. And predicate version of stood mismatch. Nice, that's already passed somehow. I guess it ran in the background. And we'll merge this when it's done. All right, folks. Robert and Fergus and everyone else that helped out in the chat. I'm trying to scroll. Yeah, Joao already signed off for the night. But yeah, thank you for the help. Fergus, you and your standard referencing was super helpful. It's probably saved me a lot of time of trying to do something that wasn't possible. And Robert, you caught a couple of mistakes that I made. This was super fun. Definitely looking forward to the next stream on Saturday and setting up the Variadic transform and growing that library, which is hopefully going to clean up this code quite a bit going forward. Yeah, this has been a ton of fun, and hope to see the folks that are free on Saturday in the stream again, and hope everyone has a good night or good day depending where you are in the world, and we will see you in the next live stream. Cheers.